Okay, so for problem 3, we've got this cute little story about Dr. Walker being abducted by aliens, taking their own planet, and of course, being Dr. Walker, being a physicist, or a physics teacher at least, he wants to know about the value of g. So he picks up a small rock, throws it straight upward, observing that it spends a total of 4.5 seconds in the air before hitting the ground, and it rises to a maximum height of 30 meters. What's the value of g on this planet? Like many problems, there are multiple ways to approach this. The most straightforward, I think, is to recall the answers, or the answer to problem 2, which was this for parts A and B. Now what you'll notice here is in problem 2, we were given the initial velocity he threw it with, or the initial speed he threw it with, and of course we knew g because it was on the Earth, right? Well, now with problem 3, we've got an unknown g and also an unknown v naught because we weren't given that in the problem. But we are given h right there, and we're given t right there, which is the total time of flight. And so what you can do, really, the secret here is realizing that, well, now we have two unknowns, v naught squared and g, or sorry, not v naught squared. V naught is an unknown and g is an unknown, and we know h and t. So what you have to do here is just manipulate these equations until you can solve them for g and optionally v naught if you want it. So probably, I mean, there's no super obviously super duper easy way to do it, but what we really want to do is we want to get g. We don't care much about v naught. So I'm going to take this equation here and manipulate it so we solve for v naught, and that's going to give you v naught equals g times t divided by 2. We just multiply the g over, divide the 2 in, okay? And then we plug that guy into here, and what we get is h equals, and then our v naught on the top is gt over 2. That's all squared, and it's all over 2g. So let's see, let's bring this down to there, and this is almost done here already. So h equals, let's see, this is going to be g squared t squared, and then this 2 gets squared and comes down there, so that's going to be over 8g, which then means that h, there we go, h equals, and the g's, 1g will cancel here, right? So h is going to equal 1/8 g t squared, and then you can solve for g by saying, let's see, g is going to equal square root of 8 times h. No, I'm sorry, no it's not. There's no square root necessary, so come on. Undo. There we go. G is going to equal 8h over t squared. And what you get there, let's see, well, when I did it, let's see, did I? 240. So what I would get then is that g was approximately equal to 240 over 4.5 squared, and 4.5 squared to be 16, 20.25. So what I got, yeah, this is about right. So g was about 11.9 meters per second squared, and that was little g on the planet Mr. Walker found himself on. So the trick to this problem is realizing that your givens and your unknowns are essentially the opposite of what you would expect, or the opposite of what you often get, and you just have to basically turn the previous solution around to solve this one.